All right, continuing on lesson 7.2. This is task 3, inverses of quadratic and cubic functions. The cube root function, f of x equals x cubed, is a one-to-one function because for every value of the function there is only one value of x. Therefore, it is not necessary to restrict the domain of the parent cubic function in order to determine its inverse function. Replace f of x with y, define the cube root, and then switch x and y and write the inverse. Replace y with f inverse of x. The inverse of the parent cubic function f of x equals x cubed is the parent cube root function g of x equals the cube root of x. In general, the inverse of the cubic function is a cube root function. The table shows some values of f of x and its inverse function. All right, again, since it's not restricted on the domain, you can see that they've picked both negative and positive numbers, plugged it in for f of x and also for g of x. All right, it says, what is the range of g of x equals the cube root of x? All right, since it's all real numbers, the range, remember, range is your y's, domain is your x's. So your range would be your y's, and this would be all real numbers. All right, is g of x an increasing or decreasing function? Where is g of x positive or negative? All right, g of x would be increasing. And you can see that as the numbers that are put in, they increase. All right, is g of x positive or negative for x less than 0? All right, when x is less than 0, it's negative, and when it's greater than 0, it's positive. All right, what are the intercepts? All right, the intercepts are 0 and 0 again. You can see when you input 0, you get 0 for both intercepts. All right, it says sketch the graph of g of x. All right, g of x is the inverse of f of x. So just a rough sketch, if I were to sketch f of x, that's the x to the third power, or the cubic function. It's going to look something like this. So this would be f of x. And then remember, if you have an inverse function, it's a reflection across the y equals x. And for some reason that shifted down. That should go through the origin. Looks like there's another graph there. I don't know what happened. All right, so g of x, it says sketch a graph of g of x. So g of x would go the opposite direction. Instead of up and down, it would go left or right. So this would be g of x. And this is a very poor drawing. But this is what I'm going to put as my answer here. So let's see. Don't know what it's doing. All right, select the arrow to show the correct graph. All right, so this one goes through sideways. This one is the g of x. I also graphed f of x went up and down. Theirs looks much better than mine. All right, confirm that g of x is the inverse of f of x. Well, I did that by saying that if you have a line that goes through here, it would be the reflection over the y equals x. They're going to do it by doing a composition of functions where they put in x to f of x, and then they put it in the next function g of x, and then they got the original values. So composition of functions shows that they are inverses. All right, select the arrow to show the graph that goes with the previous sample answer. All right, so here there's a sketch much better. This would be f of x, and the blue line here is g of x, and you can see that it is a reflection across that y equals x. All right, that's all for task 3. Lesson 7.2, task 4, inverses of quadratic and cubic functions. Determine the inverse function of a function p of x equals x squared plus 4. Since p of x is a quadratic function, you need to restrict the domain. Why must the domain of a quadratic function be restricted? All right, I put because the square root function is not a function unless you restrict the domain. The simple answer here says since a quadratic function are not one-to-one, their inverses will not be functions. Okay, which is just another way basically to say square root function is not a function. And since the square root function is the inverse of a quadratic function, that's why I put this. All right, it says, why is the inverse? Let's look at this first. It says, let p of x equals x squared plus 4 for values of x greater than or equal to 0. All right, so we are going to restrict the domain to all positive x's. Replace p of x with y, all right, and then switch x and y and solve. That's how you find the inverse. And then p of x, or p inverse of x, equals the square root of x minus 4, and that would be still restricted on the domain. All right, so it says, why is the inverse equation y equals the square root of x minus 4 rather than y equals negative square root of x minus 4? And it's because the domain was restricted to x greater than or equal to 0. All right, it says, what is the domain of p inverse of x and y? All right, so the domain of p inverse would be, the domain is x greater than or equal to 4. Any values less than 4 would create a negative number under the square root. All right, so when you put a 4 in here, 4 minus 4 equals 0. So we can't have anything less than 0 for the domain. So the domain is restricted to numbers greater than 4. All right, so use function composition to verify that p of x and p inverse of x are inverses. So they went through the process of doing the composition of functions, and it shows that p of p inverse of x is x, and p inverse of p of x is also x. So how does it work to show they are inverses? The composition of functions are both equivalent to x. So when you do composition of functions and you get the same thing, that shows that they are inverses. The figure shows the graphs of the function p of x and p inverse of x. All right, p of x was quadratic function restricted on all values greater than 0. So instead of having our parabola or our U-shaped graph, we just have this half of the parabola because the domain was restricted. That means this is p inverse of x, because when you switch the x and y, you get that reflection across the y equal x. So this would be your p inverse of x. All right, it says which curve is the graph of p of x? All right, I just said the blue line is p of x. And which curve is p inverse of x? And how do you know? All right, I know just because I know all quadratics are functions, and so it has to be a U-shaped graph that passes the vertical line test. Even though this is restricted on the domain, this is still half of that parabola. So it says the blue graph is p of x because it has a blank intercept. It has a y-intercept of 4. And the black graph is p inverse of x because it has a, this is your x-intercept of 4. So you can see that these two would switch. The y-intercept and the x-intercept, those are inverse points there on the two lines. How are the domain and range of p of x and p inverse of x related? Okay, so they're opposites. Remember, if you switch the x's and y's, that means your domain and range switch. So the domain of p of x, where x is greater than or equal to 0, is the range of p inverse of x, and the range of p of x would be the domain of p inverse of x. So you're just switching the x's and the y's. So when you switch the x's and y's, you're switching the domain and the range. All right, that's all for task 4. All right, lesson 7.2, task 5. Inverses of cubic functions. Determine the inverse function of the function p of x equals x cubed plus 4. The function p of x is a vertical translation of the parent cubic function. There is no need to restrict the domain of p of x to find its inverse function. Why is it not necessary to restrict the domain? All right, since this is a cubic function and the inverse is going to be a cube root function, both of those are functions. So that means it is a one-to-one function. All right, so replace p of x with y, solve for x. All right, so we're going to solve this. So you start with y equals x cubed plus 4, and when you find the inverse, you get the cube root of x minus 4. The inverse of the function p of x is p inverse of x equals the cube root of x minus 4. What is the domain of p inverse of x? All right, we just determined that both of these are functions, so we can say that the domain of this has no restrictions, so that means it's all real numbers. All right, it says use a composition of functions to show that p of x and p inverse of x are functions. All right, let's see if I can pull up. All right, so if I have, let me get my functions again here. X cubed plus 4. All right, so p of x equals x cubed plus 4, and p inverse of x equals the cube root of x minus 4. And we just want to use a composition of functions to show that these two are inverses of each other. All right, so to use a composition of functions, we can just pick a value of x. So let's say let x equal, let's just say let x equal 0. That's easy enough. All right, so if we plug this into one function, we take the output, plug it into the other function. If we get what we started with, then these two are inverses. So let's start with p of x. So let's do p of p inverse. Actually, that shows that we'd go to p inverse first. So let's plug it in here first. All right, so we're going to have 0 minus 4. So we're going to have the cube root of negative 4. And then we're going to take that and we're going to cube it. And then we're going to add 4. So the cube root cancels that and leaves negative 4 plus 4, which is 0. So we plugged it into this function first, p inverse of x, and then we plugged it into this one. We could also do it in reverse. So you could also do p inverse of p of x. I'm going to run out of time here in a second, but if you plug it in here, you're going to get 4. Then you plug it in the next one and you're going to get cube root of 4 minus 4. Cube root of 0 is just 0. So you still get 0 either way you do it. All right, so that proves that these two functions are inverse.